I want to demonstrate one more generic delegate that is available from the system namespace, and that generic delegate is converter. Converter is a delegate that's going to point to a method that takes one parameter of type t input. So I need to provide a type for t input. That'll be double. And then the converter has to return a parameter of type t output. So let's return a string. And that means I am describing a method that will take a double parameter, let's call it d, and return a string. So a really trivial implementation of that would be just to call double.toString. And this converter might just come in useful. You might remember earlier, what we wanted to do was write an extension method for buffer. It ended up being called asEnumerableOf, where we describe the type that we're going from and the type that we wanted to convert to. And let's say we want a date time, and some magic implementation inside of there would just turn a double into a date time. Because perhaps the items that we're adding into the buffer represent some offset from a set point in time. So given the value 3, we'd like to add 3 days to some date like January 1st, 2010. And let me console.writeLine the date. But we looked at this before, and the problem is our implementation inside of that method doesn't know how to do this conversion. So it simply gives up and throws an exception. It doesn't know how to turn a double into a date time. It did know how to turn a double into an int. It knew how to turn a double into a string. But if we look at the extension method, it's using typeDescriptor.getConverter, which only knows how to do very simple primitive conversions. So I don't really like this method anymore. I know a better way to do a conversion, any type of conversion, and give the caller complete control over how the conversion happens. That would be by passing in a converter delegate. And then it would just be up to the extension method to apply that converter to the contents of the buffer, perhaps providing some additional logic. Well, let's call this method map now instead of asEnumerableOf. I don't really like that method name anymore. It used to read well when I just needed one generic type parameter and I could say asEnumerableOf int, but now that it's asEnumerableOf double comma date time, syntactically I just don't like the looks of that or think it makes very much sense to a person reading the code. So I want to call it map instead. We're going to map each input item to a new type. And in order to do the map, I need you to pass me a converter, and that converter will need to take two generic type arguments. T input would be t, that's the type of the buffer, and then t output would be the t output generic type parameter that we already have in place. That is our converter. We no longer need to use the type descriptor to get a converter. Instead, we just need to apply that converter to each item. So instead of invoking a method on an object, we're actually invoking that delegate, passing in each item, and because this is now strongly typed, converter has to return a t output. I no longer need this cast operator. And now the code is basically saying for each item in the buffer, run the converter. And if I really wanted to simplify this, I could write this without a for each loop and just use a link select operator, because we're basically doing a projection. Basically saying for each item in the buffer, we'll call it I for item. I want to run the converter and transform I into some new type. And that will work just fine too. That returns an IEnumerable. And so you might say now, well, do we really need this extension method? Couldn't the person who is using the buffer just write buffer.select? And that's a fair enough argument. I would probably say we could just entirely get rid of this method, but let's just keep it around as an additional API that someone can use. They might want to map a buffer and not bring in the system.link namespace to include all the other link operators. And map just basically becomes an alias for select. Now back in the program, what I need now is a converter of double to date time. And let me move this variable down here where we're actually going to use it. And now to convert something to dates, I want to call map and pass in my converter, which is perfectly fine. I just need to actually fix up the converter to return a date time into a string. But like I was saying, let's pretend the values inside the buffer represent some sort of offset from a given date. In that scenario, what I could do is return a new date time value, let's say starting January 1st, 2010, but I will add that number of days to that date time. So if there's a value of 3, that should come out to be something like January 4th. Let's run this and see if it works. I enter in a 2.1 and a 10.5 and a 32, and we get back out January 3rd, January 11th, and February 2nd, so that looks correct. Notice that add days can work with fractional values, which is sometimes quite nice. Also notice that map, unlike as enumerable of, no longer requires any of the generic arguments be explicitly specified. I don't have to specify t or t output. That's because the C# compiler, once again, it can use type inference and figure out that since you're calling this method with a converter of double and date time, that double and date time must be the generic type arguments that have to be passed to map. So that just works out behind the scenes. But what if I took this lambda expression and didn't assign it to a variable, just tried to use it inline? In that case, the C# compiler, still pretty smart. It sees a lambda expression on ibuffer of double, and it can figure out that D must be a double, and it knows that what that lambda expression is returning is a date time, so it can figure out that T output is a date time. And this is actually working pretty well, because I have fewer generic type arguments in here to clutter up the code. I have a very flexible converter that can convert one thing to any other thing. I just need to provide a little bit of logic to make it happen. And it's another demonstration of how useful generic delegates can be, particularly when it comes to typing and type inference, and being able to remove cast operators and generic arguments from your code.